We have a quiz tomorrow over 1.5 through 1.9. So today I planned to just go through some example problems that you might see something similar to on the quiz tomorrow and make sure everybody's understanding absolute value equations, absolute value inequalities, interval notation, and then unit conversions, because that's what it'll cover. Okay? Okay, absolute value equation. When I solve this, how do I do it?
You write two different equations.
Good. You always write two different equations. Only exception would be if the absolute value of m equals 0. Otherwise, you're going to write two different equations. The first equation is always what's on the left or what's in the absolute value signs without the lines. And then I just set it equal to what's on the right. The second is always what's on the left, but I set it equal to what? The opposite. And then I just solve these normally. So I have here r equals 15 plus 27, 42. And what is, when I add 15 here, what's r equal to?
2. 12.
It's negative 12. Remember, when you add and subtract numbers that have different signs, it's always a subtraction problem, and your answer is always the same sign as the bigger number. So 27 minus 15 is 12, and my bigger number is negative, so this number is negative. That's an easy way to remember that. Okay, so I have two answers. If I do it in set notation, two answers that are specific, you always do the little squigglies. This means the answer is either 42 or negative 15. Notice it's not a parenthesis or a bracket. It's got the little squiggly lines. That's called set builder notation, which just means it's just those two answers. It's not between the two. It's just those two. Questions? Okay, this one, solve the given inequality. Describe the solution set using set builder or interval notation. Either one, then graph the solution set on a number line. So let's do this. What's the first thing I do? Add 6. Okay, m is less than or equal to 18. How do I graph that on a number line?
Just go
Close dot on 18, and it would go where?
all the way over.
This way?
Yeah.
It's less than.
It would go down.
That way. Yep. And it would go to infinity, right? So let's practice writing this in interval notation. Is it parenthesis or bracket to start? Parenthesis. Good. Because I start left and I work my way right, and the furthest left number this is going to be is negative infinity, because it goes on forever in the negative direction. And it goes till I hit 18, and it's got to be a bracket because that circle is closed. Infinity is never bracketed.
This is like really easy to do just because I'm not working on it.
Okay, in set builder notation would be x such that x is less than or equal to 18. Those mean the same thing. Good? Okay. Next one. Same thing. We're going to solve this, graph it on a number line, and then write it in, this time, interval notation. What's the first step? Multiply both sides by 8. Good. This cancels, so don't think you've got to multiply the numerator. I had some people on a problem in WebWork do that. Okay? When I multiply by 8, the whole purpose was to cancel the 8 in the denominator, so I don't have to multiply it by the numerator. That would be 8 over 8. 8 over 1. Remember, I can rewrite this. Is that what I want to do? No. I can switch those because the commutative property. And 8 over 8 is just 1, right? So all I'm left with on the left, on the right, is x plus 44. So I have 8x is less than or equal to x plus 44. Now what? Subtract x, okay? 7x is less than or equal to 44. Now what? Okay, how do I write this? Well, let's do a number line first. Is it greater than 0? Yeah, so it's going to be over here somewhere. It's actually going to be about 6 units and then a little more. Right? Is it a closed or open? Is it going left or right? Left. Okay, how do I write this in interval notation? Good. Okay, if the arrow was going the other way, how would I write that? Good. Good. That's the first thing I would do here. Multiply everything by 2. To get 9 minus p is less than or equal to 2. Now what? Subtract 9. Negative p is less than or equal to negative 7. By what? So what do I do here? P is good. To what? Right. Remember to flip your sign when you divide by a negative. Flip your sign. And a negative divided by a negative is a positive. Okay, good. How would I write this? Good. Okay. Hopefully this one works out when I just throw different numbers in. Okay, this is a compound inequality, meaning it's an and or an or. This time it's an or because they wrote or, which is nice. So let's solve each one separately. What do I do on the left one? Good. Divide by 3. Okay, on the right. That's 7. Hello. Divide by 5. What's bigger? Yeah, 8 over 3. Why? Why?
Because n is negative.
Well, no, because 7/5 is a positive too. Well, how many times is 3 going to 8? Twice. How many times is 5 going to 7? That's a good way to think about it. Okay. So on my number line, I know 8/3 is going to be the bigger number. You don't have to be exact. This is more for visual representation. Okay, and it says it's less than 8/3, right? And it's greater than 7/5 or equal to. Right? So this actually was an and. Right? I think the problem on the quiz, I changed the numbers, so changing the numbers changed this to an and. But I could see that by graphing it. How do I represent this as an interval notation?
That's what I meant to say.
Parenthesis, yep. Okay, what if, let's think about this one. It started as an or, didn't it? An and means I would go here and stop and then go here and stop because it's got to be an and. But an or, this arrow really goes on forever. And this arrow goes on forever. And because it's an or, I don't have to include just the ones that meet one or the other, or one and the other, I mean. It can be either or. So this is going to be similar to something on the quiz. Okay, if you end up graphing it, and it started out as an or, treat it like an or. If it says and, treat it as an and. It said or, so it can either be greater than 7/5, and what number is greater than 7/5? 3, 4, 5, 6, 7 to infinity, right? Any of those numbers is greater than 7/5. Or it can be less than 8/3. So any number less than 8/3 will qualify. If it was an and, it has to be both. Greater than 7/5, less than 8/3. So it's just that little narrow window. The or, it can be either or. So in this case, it's really going to be all real numbers, which I could represent this way. On the quiz, did they do it in interval notation? No, they use this. This means it's an element of. What does this stand for? When you see a double, like a double line, an R. It stands for all real numbers. All real numbers. Okay? So X is an element of all real numbers. That's what this means. And your graph then would show arrows going in both directions to infinity. Okay? So on the quiz, make sure you're reading those ors and ands. If it says and, it's got to be a combination of both, so it's going to stop. If it says or and both of them are going in opposite directions, it's going to be going to infinity in both directions. Does that make sense? Okay. Hopefully nobody misses that one. Next question. And this time it's an and. So the first thing I do is what on the left? And over here, first thing I do? And this is an and. Okay, so it says P is greater than -5, open circle this direction, and P is less than 2. Okay, the only answers that would meet both of these are the ones between those two numbers, right? The last problem, we could go forever. So let's say it's -6. That would meet this one, but would it meet this one? No, which is why it's just going to be between the two. So if I write this in interval notation, it looks like that. Questions? Pretty easy, hopefully. Okay, how about this one? Now we have absolute value inequality. So what do I do to set this up? Two different inequalities. The first one looks exactly like the original without the absolute value. What's the second one look like? And it has to flip, right? Now I just solve both of these. I add 7. So is this an and or an or? Well, the easiest way is to just graph it and see. It's less than 11, greater than 3, not or equal to. So it's an and. Everybody try this one. Need a piece of paper? You need a piece of paper? So what'd you guys get? 12 and -2? So I'm going to add 5, and then add 5 here, Good. Let's try one more together. Let's make it greater than. Make it 9. You figure it out, Ian? Yep. Okay. So is this an and or an or? Did you do your number line? So let's try it. First thing I do, write it exactly as written. Next thing I do, change the sign and make it negative. Now I'm going to solve both. -3. So it's greater than or equal to 5, and it's less than or equal to -1. And or? Good. Okay, so I could write this as x is less than 1. This would be x such that x is less than or equal to 1, negative, or x is greater than or equal to 5. That's set builder. Interval notation would be what?
Bracket -1. Wait.
Start left. What's the very first number on the left? Okay, let's do a conversion. Everybody good on absolute value equations and inequalities and interval notation, set builder notation? We're all good? Okay. Okay, everybody try and convert 3 feet per second to miles per hour. And I'll tell you 1 mile, if you don't already know. And hopefully you guys know how many seconds in a minute and minutes in an hour. Okay, everybody give this one a shot.